This is University of Colorado Television. Experiments in Physics with Dr. Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment
This is an Atwood machine. It's basically a very simple piece of apparatus. It has two weights, one here and one here, tied together with a string which goes over this pulley, and one can study the effects of uniform acceleration with that. The weights are equal. Of course, if I put one near the top, then there's a little more string on one end side of the pulley than the other, and they're not exactly balanced, as you can see, but that's a fairly small effect which you can take into account. In using the machine, one wants to be sure that the pulley is free, that is, that there's no undue sticking, and that the bearings don't have too much play in them. There are adjusting screws here, and they can be lightly oiled. Also, in using the apparatus, before using it, one wants to make sure it's vertical, and that's an easy adjustment to make with this apparatus, because this weight passes through this plate, and one can simply adjust it so that the weight goes through the center, is in the center of the hole. And that's done by these two adjustments here, which tip it from side to side and get it through the center of a hole, and another screw in back here, just behind this screw here, which can be used to move it in and out, and also to get this weight in the center of the hole. These devices move up and down, and one can vary the distances. Similarly, this one can be moved on this slide with loosening the little thumb screw here. And the basic operation of the apparatus, I'll illustrate before going through it too much. It just slipped off the pulley. Happens every once in a while, but isn't serious. And then one can set this little platform up here, and there's a little ball on that catch, and one sets that just underneath it. And then one can produce a net force by putting a weight on here. This is a 5-gram weight. And let this sit right down here so that it doesn't swing when we release it. It's right under the center of the pulley, and then we can see what happens. There's a counter which will measure the time here. We'll look at that more carefully in a moment. But when I release this, the weight will be removed by this device, and let's watch what happens. We'll do it again later. And that's all that's really involved in taking data on this experiment. During the first part of this trip, that is from here down to here, this weight is on here, and it's removed by this lever here. When that happens, let's look at this micro switch a little more closely. Notice that as soon as the weight hits that, it drops. And when that happens, provided this switch is up, the counter will run. When the switch is up like that, the counter stops. So that when the weight hits it, the counter starts running. Then this weight goes on through, and it goes through at a constant velocity since there's no acceleration. And when it hits this, it stops the counter. So one can measure the time it takes for this weight to go a distance from the top of the weight here to the bottom of the weight here. That is the distance between here minus the length of the weight. And if one knows that time and knows this distance, one can measure the velocity. Of course, there's some friction. Notice that if it's moving very slowly, it stops, so that you may want to vary the distance here for a given distance at this point in order to determine what the velocity was when right at the point that this switch closed. So you can take a number of measurements for different distances here, for the same weight and for the same accelerating distance. Then you can vary the accelerating distance and see what the effect on the final velocity is using both this 5-gram weight, and if you want larger weights. And also there's a heavier set of weights, ones that are about twice as long as this, which you can use in place of these lighter weights. And by doing that, you can actually calculate what the effect of this pulley is and eliminate its effect and understand just the effect on the total mass. I think those are the only precautions that one need to take. Of course, one has to remember to reset the counter before each measurement. These switches have wires coming out of them which indicate the common lead and the normally open and the normally closed leads. And this switch up here also has wires, and if you want to, you can rewire the device so that instead of measuring the velocity after it traveled a certain distance, you can actually measure the time it takes to accelerate this distance by putting this switch in there. This counter counts whenever this circuit is closed and stops counting whenever the circuit is open. So by using the labels on the wires, you can arrange it in any way you want to. But even if you don't do that, you'll have to take a considerable amount of data with different positions and different weights in order to make the experiment worthwhile. That's all.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television.